Why do I pose this restriction that the attacker has to have some limited amount of computation time? Great question, yeah. Suppose that I had an attacker who had an unlimited amount of computation time. They could do, like, computation that would be totally infeasible today, so it's just a thought experiment. It might take, like, longer than the lifetime of the solar system to finish the computation, but just open yourself up to that possibility. What kind of attack might be possible for an attacker? Brute force. Yeah, you said brute force. Brute force every input. What kind of input do I want to brute force? Which of the inputs? There's 2 inputs to a block cipher. Change the key. Well, as an attacker, you don't get the option to change the key. Notice how this security game works. The key is not under the attacker's control. The key is chosen once. And that kind of makes sense because if we think of Alice and Bob are communicating and the attacker's trying to figure out what they're sending, the attacker doesn't get to control the key. Alice and Bob chose the key once, and they're going to pick one key and stick with it forever. So you... Okay, all right, I see where you're going. So I like what you said about the key. The thing is, we can't force Alice and Bob to use a different key, but the attacker can do their own computation. Simulate all possible block ciphers. That's interesting. I like that idea. We don't actually need to simulate all possible block ciphers because remember this Kirchhoff's rule, no security through obscurity? We should assume the attacker knows the block cipher algorithm. But what does the attacker not know? The key. So the attacker could simulate all possible keys. Could feed in a word, look how it's encrypted, and then try encrypting that themselves under all possible keys and see which one gives a matching output. Okay, so that's called exhaustive search or brute force search for the key. So that would work to recover the key. Now, if you had a 256-bit key, how many of those encryptions would the attacker have to do? 2 to the 256. Yeah. And that is such a huge number, it's take you longer than the lifetime of the solar system to do that much computation. It's not a realistic threat. It is possible in this imaginary world where we had attackers who could do unlimited computation. But in the real world, attackers can't do unlimited computation. We don't really have to worry about exhaustive search over all keys because we choose a key length to make that infeasible. And so that's why we to come back to your question, that's why we put this restriction on efficient attackers, because I don't want to impose an unnecessary requirement that we have to stop attackers who will take more computation time than the lifetime of the solar system. That's not necessary. It's just necessary to stop attackers that, might succeed within my lifetime.